Ha! Great, I'm back. What is that? Okay, here we go. Let us do some Boggle. Ha! Here we go. Okay, so I'm in Eclipse. Why Eclipse? Because that's what I learned to use. I used Emacs right up until 2004, and then my advisor kept trying to convince me to use an IDE, and I was like, no, I'll just use Emacs, but I wasn't really that productive with Emacs, and then I switched to a project that required that I use an IDE, and that changed my life and made me, I mean, no joke, probably 10 times as productive as when I was just doing everything with like a text editor and compiling from the command line. I was using I didn't even really know how to use Ant that well, so I was using Make a lot rather than Ant. It was a disaster. This is much better. So, as you can see, what do we have for Boggle? I always start, and you can't see any. Well, here, I'll put the link in. So when I switch windows, you can't see me doing that. I tried to set it up so that you could see my Firefox window and also, my Eclipse window, but I don't know how to do that because I don't know what the hell I'm doing. So, I'll figure that out later, or something along those lines. But basically, I've got this on. Do I have this somewhere? Yeah, here we go. Here's the template that I'm doing this from. It's on REPL. So if you want to ever play along, here's your, you know what? I'll do like a real comment. Good. There we go. So REPL. You can play along on REPL here. So I've got this template, and the reason I have a template is, as we all know, Boggle. I would also like to show pictures of Boggle and things like that, but I really can't because I'm kind of only showing the one window, and I don't want to show all my windows because then, I've got 50 million things going on, which probably you don't need to read my email. That's probably really, really bad form to stream reading my email. That's probably not great. Oh my God, somebody said something. Ha! Somebody named Doot Doot Boots. Ha! I have a viewer. God, I feel like a celebrity. Oh, man. Oh, this is so fun. I've really arrived. This is probably, probably the biggest catastrophe to face the United States probably since the Depression and World War II, which probably wasn't even as disruptive economically. Maybe close. Probably the Depression was as disruptive economically, and it's finally allowing me to just stream and say that it's work. I'm probably this. Yeah. Anyway, so I should be. It's like this whole thing is leading to my skill set. Talking to students a lot and working on random things that are interesting. So here's what's going. Oh wow, this formatting is terrible. Yeah, that looks better. Okay, good. So, Boggle, what can we do? Well, okay, I'll make a Boggle board in a second. It's, just Google, oh wow, I'm buffering. That's weird. Use the low latency under the advanced menu to disable this. Okay, what if I do that? Is that on my end? I think I can fix that on my end, actually. I can get rid of this now. Latency. Normal latency. Yeah, I'm not going to be real-time interacting with viewers. If anybody viewing this is going to also be in the Slack, and so just ping me on Slack if I'm not responding quickly enough. I'll fix so that should hopefully fix the latency issues. Okay, good. So, and I can't show you any other windows, which really is stupid. Okay. Somebody figure out, I need to figure out how to, switch windows so that I can show you both this window and also my Google window so I can Google various things to show you. I mean, I can kind of, well, you know what? I can do it. Boggle. Yeah, I'm just gonna do. Okay, watch this. Well, this is kind of a disaster, but it'll be fine. No, that's not what I wanted. Window capture, and the window I want is. That's fine. Yeah, okay, is... No? Firefox. Right. Good. Bam. Alright, now... Yeah, okay, you can see that. And I'll just come in here and... Well, you can sort of see... Wow, that looks terrible. How do I make this the right size? Why would you do that? Does it matter if I make the window smaller? Does that help? Well, that looks terrible. What if I make it this small? Well, this is a disaster. Wow. Wow. Okay. But that isn't really what I want. What I want is to just get the whole effing window. Okay, that's a total disaster. Well, maybe I'll just show it up in the corner, maybe? Boggle? So, Well, maybe you can see it. Here we go, this one. So as we can see with this one, Boggle, it's this game. You can kind of see it up here. It's like you got these dice, and you put them in like a little cup, and you shake up the cup, boom. And then, yeah, here it is. You can see it. Hopefully you can see it right there. There's a little plastic thing that goes over. The dice rattle around. They each go into a different spot. And then you have to try to make words. And I think the words have to be at least 3 letters. I don't think you can do 2-letter words. Maybe you can do 2-letter words. I can't remember. I don't know. It doesn't really matter. It's just a setting in the code we're going to write. And so you end up with something like this, and then you have to go through and find words. So you're like, oh, okay, VAT is a word, V-A-T. And then, wow, there aren't really that many. Well, I'm not. P-A-L, pal, that's a word, P-A-L. So you start with P, you go to A, you go to L. That's acceptable. But you can't do like P-A-L-P, assuming palp is a word, which it isn't, but pretend it is, because you can't reuse letters, right? So if you've done P-A-L, you then can't go back to P, but you could do P-A-L-S, pals. Yep, there's a word. Boom. And you can do, T-A-N, tan, or T-A-N-S, but you couldn't do T-A-N-A, tan, or something like that. So those wouldn't be allowed. And so what's really cool about this is, first of all, it's a grid, and I just love grids. They're easy to print in text. They're easy to generate in, just really simple Java code, so I really like that. But then also, this process of like starting with this letter and then going to that letter and then going to this letter and keeping track of what you've already seen, it's just a really nice recursive algorithm, and everybody loves recursion, and by everybody I mean me, and hopefully, from watching this, you. So that's what's going on. Oh my god, some other... Would pressing Control and minus help zooming out? I don't know. Let's try that. Did that do anything? No. Sort. Oh, that's slightly better. I certainly can, like, zoom out a bunch. I can only zoom out so much. You can see more now, but it's smaller. Yeah. That is too Galaxy Brain for this stream. Please tone it down. Oh, that's fantastic. I don't know what Galaxy Brain mean. That must be what, like, the kids these days are saying. I have no idea. Okay, so we're going to do Boggle. We're going to do... I don't know if we'll get the GUI working. We'll see how it goes. Okay, well, now I need to go here and drag this capture. Do I just to remove it? Or do I just move it out of the way? I don't know. Well, I'll just stick it in the back for now. Now we're back. Okay, that's not that bad if I need to Google things. Okay, so if you want to play along at home, here's your template. And the hardest thing in Boggle, not hardest, but the most tedious thing is the dice, because each die has 6 faces, and so when you sort of shake them up and then bam, lay them out, in the physical game, each of these dice can turn onto any face, and it can go into any of the 16 locations. It's a 4x4 grid. So what I always do is pre-create just a really simple class for the die. Let me make... You know what? I'm going to make the font even bigger. So I just looked this up. Yeah, here we go. General, appearance, colors and fonts, text font, edit. I'm going to go to, I don't know, what do you think, 18-point font? All right, I got to close that. Apply and close. That's better. And then, because I don't really need the outline over here very much. I mean, I use it sometimes, but I don't really need, there's not much over here. There's only like a couple of little things. Oh, and you can see Connect 4. So theoretically, if this goes well, I'll do Connect 4. Because Connect 4 is harder, and you definitely want a better GUI for Connect 4. Okay, so anyway, class for die. I'm just representing it, it's a class. What instance variables? Well, it's just an array of strings. And the reason I had to use string instead of char, little known fact about Boggle, and by little known, I don't know if it's little known, Q is actually QU because in the English language, anytime you see a Q, you have to see a U after that, unless it's like certain proper names like the country of Qatar, and certain abbreviations or acronyms or something like that. But proper dictionary words always have QU. So we couldn't use char. We had to use a string there. And then, so I have this constructor where you enter the 6 strings. It just goes ahead and creates an array out of that. And then I've got this roll method where you give it a random number generator, and then it's going to just sort of, do next int of 6. This gives you a number from 0 to 5 randomly. Of course, nothing's really random. It's probabilistically random, so it's based on whatever the seed value is, and then it returns the letter there. So it's just a really, really simple class. So I've got that, and then I've got this, and I always try to have that pre-created when I'm going to sit down and do this, because it's just tedious to get all those details right. So here I have an array of these 16 dice, and then each of these is the correct dice. And I went and looked this up somewhere. These are what the actual dice are in, the Boggle game that I owned at some point. And so I've got this class called board. The reason I'm calling it board is this is going to be the Boggle board. So the first thing we need to do is randomly assign those dice to a 4x4 grid, and then we need to randomly roll those dice so that one of those particular faces comes up, and then we need to print it out. So, what do we need for that? Well, I need some way to store, where the dice are. So this gives me all of the dice, but then when I go ahead and roll the dice and put them, I'm going to need a 4x4 grid. What do I want to make that grid? I'll probably just make it string. So I'll do something like string. Okay, well, there's 2 ways to do this. This is sort of interesting. One way to do it would be to just do it as your standard sort of 2D array with a 4x4 grid. Another way to do it would be just to do a 1D array, and then have the get methods do modding and stuff like that to find everything. Are there advantages or disadvantages to doing it either way? I really can't think of any reason why one matters particularly over the other, because obviously once we get the data laid out, we're gonna, so here's what I'm getting at, is we're gonna have public string get letter, and we're gonna say int row int column, and this is going to get the letter at the given row and column, and so how that data is represented doesn't really matter. This is called, model view controller. There's not really a controller. It's really model view. The model, how we're implementing it, is sort of different than how we're accessing it. So the view is going to say, get me the letter at this location. But then we don't really care, is that a 1D array, 2D array? Nobody really cares. So let's see. How are we going to do this? Oh, the other thing we need is we need the random. Private random, I'll call it rand, and we need an overall constructor. Let's do public board. I'll just make it the void constructor. And so what is this going to do? Oh, I already had one of those. What am I doing? That was down here where it created the array of dice. Well, that's interesting. Let's do it this way. So we've got this constructor. Let's make a second constructor. This is our Miranda rights constructor. It's not really because it's got code in it. Public board. That's a joke I use all the time in class, I should mention. I call it the... What do we got here? For clarification, what are you doing? How many times have you made a Boggle game? Okay, I'll answer some of these questions I've got in chat here. What am I doing? I'm implementing Boggle in Java because it's a really cool recursive algorithm and, shows off some basic data structures and functions of Java. I wanted to do this anyway because I want to have the code and I want to be able to show it to students. And I like to do this every year or two so that I remember how to do it because it's a good, I've done this before, but it's a good recursive algorithm, and I like to redo it periodically to make sure I remember what the heck I'm doing. What else do we have? How many times have you made a Boggle game? I don't know, probably 4. I've done it in Python, I've done it in Java. I've done it in Java probably a couple times. So what I'm trying to encourage people to do, students especially, something I noticed in the intro class years ago, I accidentally put on an exam a question that was on an assignment from a couple weeks earlier, and so I figured, oh, well, everyone's going to get that right. That was a big blunder on my part, but then they didn't because, and it was an open book exam, but students didn't have every previous assignment. So, just because they had done it 4 weeks ago, people didn't necessarily remember how to do it. And so there's this difference between, being able to do something well enough so that you earn credit for it, but then being able to know something well enough that if you had to do it again in a month, you could still do it. And so programming is like that. Just because you did something a while ago, do you still remember how to do it? Did it stick? So let's do this. Can I do that? Yeah. Oh, no, I don't have... let me think. Do I have to do that? Well, okay. Let's do this. Okay. So let's do... Here's what I'm trying to do. Here's the decisions I'm making right now. Here's what I'm thinking about. Basically, I want to make... Okay, I should back up a second. What am I trying to accomplish to start out with? So I've got random, and I want to pass this in. And the reason I want to... in other words, I don't want to create it with a new seed every time. And the reason I want to do that is I want to be able to pick the seed. So I want to pass this into a constructor so that when I'm testing it with a main method, I can do that. So I can pick the seed for it. And then I want every part of the program just to use this random number generator, which is why if you look at this die class, this roll method, you have to pass it a random number generator. You don't want each die to have its own random number generator for a number of reasons. Mainly, they'll generate the same sequence of numbers. And the reason for that is if you create a random number generator and you don't give it a seed, it just makes one up. And what it usually uses for the seed is the timer, which is the number of milliseconds since January 1st, 1970, more or less, is like a long. And so when you run your program, creating an array of these, dies, if each of these created its own random number generator, all of this would probably happen in the same millisecond, which means all of these would probably generate the same sequence of numbers. Now, it would be a little bit different because, they would all generate zeros, they would all generate ones, or they would all generate twos or something like that. So, it would sort of look okay, but it would be a little bit weird. We want to actually just have one random number generator, and we want to be able to pick the seed ahead of time. So what I'm getting at is what I'm going to do here is I'm going to do public static void main string args. And in here I'm going to say board equal new I'm going to do random r equal new random, and I'm going to pick a seed for it, 1L, and I'm doing L here to emphasize that it's a long. If I don't do that, will it work? Oh, it still will. Never mind. It can take an int or a long. So I'm just picking 1 as the seed. I could pick any number I want there. I'm just doing 1. So I'm going to make this. I want to pass in R, and then I want to print it. Oh, well, isn't that nice? How about never show me that again and just go away without thinking about it? Hey, look at that. Yeah, so I'm going to print the board. And so this should just print the board, whatever it looks like. That's my goal to start with. And then once I have that, so this way, you know, if I run it a bunch of times, because I'm using the same random number generator, I should get the same board. And then if I want to play it where I don't get the same thing, then I would I would obviously go ahead in here and change this to just something like this, where now it's just going to use whatever the timer is, and it would be different every time, but I don't want that right now. Right now I want this. So I'm just trying to get like the basics done so I can do some testing. Oh, this is exciting. Here we go. I've got more people. Who is everyone? Oh, look at that. People are in the... Look, people have like waving icons. Oh my god, this is so exciting. How long until I lose people? Who knows? So I don't know how to use Twitch very well, so I have like a older laptop over here where I just like have my own stream open. So one of the viewers is me sort of anonymously watching myself, which is like a little weird. But that's where I can see the chat. I can't see the chat over here, so that's why I have to keep looking away. Okay, so what do we have? We got this. This is great. This is what I want to get to. So, and what I was trying to, and the issue I was getting at is if I make this constructor, I want this constructor to call that constructor. And I'm pretty sure the way you do that in Java looks like this. This is this weird syntax. This is telling this constructor to call another constructor. So you probably never knew that this could be used as a method, but I think it can. But I think this is really a bizarre and ugly way to do it. So what I'm thinking about is maybe doing it like this, saying like private void. Wow, that was weird. Private void init dice, and yeah. Blah, 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 blah. Take this, Shazam, and then drop this in here. Whoop! Okay, good. That's great. And then, now I can actually get rid of this constructor. I don't need a void constructor. Well, let me leave that in for a second so I can tell one of my, like, 3 funny... Well, and by funny, I mean not funny. They're computer science dad jokes, basically, because I'm old, and I'm a dad, and so I tell dad jokes. It turns out there's no difference between dad jokes and professor jokes. They're basically the same genre of joke. Anyway, so as we all know in Java, if you don't provide any constructors, Java does provide you, it's a default constructor, which takes no parameters, so it looks like this, and it just initializes everything to the default value. So all of these will get initialized to null because these are reference types, and so that's the default for everything in Java. So it's not a very good constructor. So I always joke it's the Miranda rights constructor, because if you watch cop shows in the U.S., you know, anytime they arrest somebody, they have to read them what are called their Miranda rights. So you have the right to remain silent. Anything you say can and will be used against you in court of law. You have a right to an attorney. If you can't afford an attorney, one will be appointed to you. So it's that default attorney that the court appoints to you. And there's this whole history of how, you know, court-appointed attorneys, like some of them are like heroic public defenders, like working for... the Innocence Project or the Southern Poverty Law Center or something like that. But then some states, just the bar to be a public defender is extremely low, and you have to have this huge caseload. They're basically the adjuncts of the lawyering world, people that are like overworked and don't really have any resources. Anyway, that's a whole social justice rant I won't get into. But what it leads me to is I always call the default constructor the Miranda rights constructor, because every Java class has the right to a constructor, and if you can't afford your own constructor, Java's just going to go ahead and provide one for you. It's just a very defaulty constructor. It's not like a fancy splashy constructor. Anyway, so what do I want to do in here? I want to initialize the dice. I'll call that private method. So that gets me my array of dice. Now what I need to do is get those dice onto a grid. So now I need to I think I'll just do the obvious thing and not get fancy, and I'll just do grid, and what I'll do in here is I'll say grid equal new string, and I want it to be 4x4. That's exciting. Oh my gosh, people have pictures in the chat window. This is so cool. Who are these people? Huh. Well, somebody will have to explain to me who these people are. Remember, I'm old, and so one of your jobs this term is to explain to me what all the kids these days are doing with all the things the kids these days are doing. Don't worry, I've got a second thing of tea when that one runs out. Just fear not. I'm ready to go. At least for a little while longer, and then I'll have to stop because it's beautiful out and we're going to go for a walk. Okay, so we got our grid. Now what do we need to do? Well, we need to go and, assign all of these, rearrange these dice or something like that. and then randomly assign them to some location. So how am I going to do that? What's the best way to do that? I want to randomly shuffle up the dice. Well, here's an easy way to do it, is I'll just go through, I don't know, int I equals 0. Oh, you know what? What am I doing? This dot rand equal rand. I need to assign my actual instance variable. So now I have my random number generator. I initialize my thing of dice. I just made this a private method, private helper method. So I equals 0, I less than dice dot length, I plus plus. Wow, I have a really short attention span. Is this like, I'm just realizing this now as I try to articulate how I'm programming. Okay, so I'm going to go through. Here's what I'm going to do. Now I'm going to int. I'll call it basic. Well, I'll just go ahead and do it, and then I'll tell you what it is. R.next int 16. No, I called it rand, not R. And then what I'm going to do is I'm going to swap them. Now, of course, what I'm thinking about is, okay, what if location is the same as I and I just swap something with itself? But do I really care about that? I probably don't. I probably don't care. So let's do this. Now I need... Oh, swapping in Java is so annoying. Am I going to write a method for swapping? Am I really going to do that? No, I'm not. Let's do this. Okay. Die temp equal dice of I. Now I can say dice of I equal dice of location. And now I can say dice of location equal temp. So that swaps it up for me. Great. Now what I want to do... Okay, now I've shuffled all the dice. So I've swapped them around. Now I'm going to go through them again. And then for this, I'm going to do... Here's what I'm going to do. Yeah, okay. I'm going to... Well, there's two ways to do this. I can either write a for loop that goes through this, like a nested for loop, or I can write a for loop that goes through this, and this would go I0 to 15 and convert to 0 to 3, 0 to 3, or I could go through 0 to 3, 0 to 3, and then convert to here. Which way do I want to do it? Doesn't really matter. I'll just do I equals 0, I less than dice.length, I plus plus, nope, plus plus. Great. Oh, these are the emotes I yell in class. Ha! If you hover over the faces, it will say what it means. Okay. Hey guys. Lol. PogChamp. Great! I'm loving this. This is... See, look at all the stuff that we're learning. This is so fantastic. Okay. What am I doing? I'm live. Manage my stream. Let me just make sure... Wow, there's actually 4 people watching this. Ah, this is amazing. Okay. Right, okay, so here's what we're going to do. Now what we want to do is we need to get a row and a column out of it. You know what? Screw it. I'm going to do it the other way. Int r equals 0, r less than 4, r plus plus. Now I'm going to do 4, because I know how to do it this way. So I have to think less, and I'm lazy. Now watch this. Out here we just say int index equals 0. Now what we're going to say is our grid of row column equal... Now watch, here's where I'm going to use the index, which remember we started out at 0. Dice of index dot roll, and I'm going to roll it using our rand. I think that's what I'm going to do, because I'm pretty sure if we hover over this, this returns a string. This is a grid of strings. Good. Now we remember to do index plus plus. Good. Okay. It's all coming together. Yeah, so here I'm just iterating through in 2 dimensions, but then I have this other counter, and then each time I use it, I'm adding 1. Life is good. I think this will work. I think this will work. But in order to test it, what we're going to need to do is a toString. So public string toString. What are we going to do? Okay, so watch this. String buffer buff equal new string. Well, let me just use autocomplete to make that go away. Autocomplete can make a lot of typos go away. So now we'll do for, and then I need to implement this method. Gets the letter at the given row column. That's easy. Grid of row column. Now I'm going to do everything in terms of this method. And the reason I want to do things in terms of the method as much as possible rather than in terms of the grid. The grid is a 2D array, which is low level. This is a method. It's very elegant looking. But I can also put stuff in here like, okay, if row less than 0 or row greater than or equal to 4 or column less than 0 or column greater than or equal to 4, throw new index out of bounds exception, Java string dot format row. How do I do this? Is this just %d column %d out of bounds? Oh, now clearly I need to word wrap this. And here I'll do row comma column. I think that's how that works. So this is like, these are the placeholders, %d. This is like old C style format strings. So like Java started out without that, and then now it added it back in. So we've all gone back to the early 70s. I feel like I should put on bell bottoms. Anyway, so I'm going to use, now that I sort of like, once I've done the low-level configuration in the constructor, I'm going to stop, and I'm going to start using this getLetter method at this higher level. Yeah, so, okay, so int r equals 0, r less than 4, r plus plus. For int c equals 0, c less than 4, c plus plus. Now watch this, buff.append. And what am I appending? Get letter of row column. And then buff.append. I guess I'll just do a space. And the reason I'm using a string buffer to do the appending rather than a string, strings in Java are immutable, so every time you do a concatenation, it has to sort of like create a unique new string. String buffers are not immutable, meaning I'm actually changing this string buffer, and at the end I'll just convert it to a string. This is the standard way to do things. It's slightly higher performance. Now I can do buff.append new line, and then at the end here I'm going to return buff.toString. Okay, great. So now, well, I don't know. Let's run this and see if it does anything. Wait, how do I forget how to use Eclipse? I haven't used Eclipse in a long time. Run. Yes. Ha! That looks very reasonable. I don't know. Let me try with a. Let's just fire away. Try this again. Boom. 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 I don't know. It looks great to me. You know what? I'm gonna do. We do have this problem with the QU shows up like in this position. Everything's gonna be weirdly offset. So, do I want to fix that? I could fix that, but I'm not going to fix it yet. This is just a printing issue, so it's isolated to this method. I could always come back and doink around with this method and try to mess with it, but I don't have to, so I'm not going to do that right now. I'm just going to kind of wait. Well, this is so exciting. This is one of the most fun things. I'm glad we're able to... I have 5 viewers now. God, I feel so powerful. There's a lot of words in here. You're not wrong. I guess I can quit. Yeah. Sorry, I went and looked at my, I saw my to-do list, poke through from behind all the windows I have open, and I was like, God, no, go away, to-do list. Okay, we're going to go back to this situation. Yeah, look, you have the word Titan. Titan. Whoop. Okay, so let's try it again. Well, okay, good. So you can see every time we run it, because we're using this with the same seed, we're getting the same output. That is really, really, really good, because we're getting something that's random, but it's the same randomness every time. That's so important for testing. Okay, so now what do I need to do? Okay, now here, I learned a new trick in Eclipse. Watch this. Boom. Now I need to tell you what the algorithm is. So for this algorithm, it's recursive. We're going to be like, okay, you can think of it as I'm firing off 16 processes, one starting at each location. So one's going to start here, one's going to start here, one's going to start here. And what are they going to do? They're going to say, okay, what letters have I seen so far? Nothing. Now I've seen T. Then it's going to do a recursion for all of the neighbors, so O, E, and H. So maybe we do the one for O. What letters have I seen so far? T. Now I add an O to it. Is that a word? Yeah, it is. It's the word two. So assuming that we're allowing two-letter words, we'll go ahead and throw that in. And then we'll do another recursion. E. So what letters have I seen so far? T-O. Now what am I seeing? E. So now I'm seeing T-O-E. Is that a word? Yes, it is. So add that to my list of words. And I'll continue my recursion. Because I should probably back up a second. What I'm doing is I'm not building something for people to play Boggle. I'm building something to solve Boggle, like figure out what all the possible words are. And then once I know what all the possible words are, then if I were to build the game, which I probably won't build all of it, at least not today, then what I'll do is, have a situation where, people can enter words, and then I'll check if the word is in one of the... So I'm producing all the possible words you could make. So I'm going to do this recursively. And the other thing I need is a dictionary. So if I look in here, I don't have a dictionary. So what's a dictionary? Well, it's just a list of words. Do I have that on REPL? I might have, put that on REPL. I don't remember. Let's find out. And again, you can't see me doing this, but, life is hard. Do I have a dictionary in here? I don't. Well, that was stupid. Okay, well, I need to get a dictionary. Where do I get a list of words? What do I want to use? I don't know. Let's use the... what do I want? The Linux dictionary? Unix dictionary? Unix dictionary. Wow. Doing that shift minus made it... Yeah, words, Unix. Well, you know what? Let's... Actually, does Boggle have a dictionary? Boggle dictionary text file. Hey, what do you know? It auto-completes. Go Boggle dictionary text. Somebody's got one on GitHub. Okay, great. I'll just download it. It's a 2.38 megabyte file? Holy moly. I don't want a file that big. How many words is it? English words. 479k words. That's a lot of words. Wow. How big is this one? Word list. What? You know what? Let's just... You know what? My first instinct was to use the Unix dictionary. Unix dictionary text file. Get me that. I would like to download it. Well, that's very slow. But this is probably showing it to me. Well, of course it's slow, Spacko. You got a million windows open. An English word list. What? Oh my god. Well, whatever. This is, I should have done this ahead of time. Wow, this is way harder than I thought it would be just to get... You know what? Okay, fine. Dictionary text file, Unix. It's in... Right, I know that. Fine. Let's just go back and get... dictionary text file. Okay, fine. 479,000 words on GitHub. I'll take it. English words. Words.txt contains all words. 4 megabytes. Wow. Wow. No, I don't want that. Let's take the 2 megabyte one. Wow. This is insane how many of these things there are. 84,000 words. That's 220K. That's fine. That's all I need. Fuck's sake, that's all I need. Open with... Oh, it's a zip file? Oh my god. Well, fine. Save it to wherever. No, how about downloads? Just throw it in downloads with every other thing in the world. You can't see any of this happening, but basically I just Googled a bunch of things, cursed at it a little bit, and now I'm... Yeah, good. Let me open this. Good. This is what I was looking for. Yes. Alright, now I need to get this into Eclipse. Doesn't that suck? Okay. Sorry, Eclipse, I've got to move you for a second. So that I can drag this in there. Wait, there we go. Copy. Boom. Done. Is this as fun as you thought it would be? Or is it more fun? Is there word list from the try assignment? Yes, there would be. That would have been smarter, except I have the wrong workspace open. So I didn't think about that. Ing mix. I'm going to rename this. Rename. Refactor, rename. And I would like to rename this words. Cool. Okay. Wow, that was much harder than it needed to be. Okay, so let's get rid of this. Well, whatever. It's fine. Good. We have a word list. So now, one of the other things we need to do is read this word list. Now, do we need it as a list or do we need it as a set? Okay, so other things to explain. I'm producing all the legal words that this particular Boggle board could produce. So what does that mean I need to keep track of? Well, I need to know what spots I've already visited. I don't need to know what letters I've already visited because the letter T can legitimately show up multiple times. I need to know that I've already seen the T at 0, 0, so that when I go T to O, I can't then go back to the T. So I need some visited list or visited set. Also, you know, maybe I'll see like V and then G. Now, there's no words in the English language that I'm aware of that start with VG. So once I've done VG, I don't need to also do L. I could just stop that recursion. So for our recursion, one of the base cases could be I've used up every possible letter, like I've gone T, H, I, H, V, and blah, 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 and gotten back to here. There's no other legal letters I could look at, so I just stop. But if I do that recursion for every, like starting at everything and then doing a recursion for everything around it, that's exponentially big. Maybe it's not exponential, but it's probably exponential. It's too big. So we need to have a way to cut off the recursion. So one of our base cases can be, you know what? HV doesn't start any words in the English language, so therefore HVN is also not going to start any words in the English language. So what I'm getting at, of course, is, yeah, we're totally going to do a try. Ooh, is there a word list from the try assignment? Yeah, there totally is. Oh, Michelle's here. Hi. Yeah, there totally is. I should have thought of that. Okay, so it's good to be heckled by my students. Not really heckled. They're not. Students are very nice to me, but, you know, everybody's home. There's nothing to do right now. So, you know, heckling Spacco while he implements code that he's done a bunch of times. This, like, what could be better? You know, what could be better? Okay, so I need to read this in. How am I going to read this in? I'll do it in the constructor. Because why the hell not? And I'm going to put it in a set. No, I'm not going to put it in a set. I'm going to put it in a try. What am I doing? Duh. Okay, watch this. New. Okay. Can I show you new class? And I'm going to call this class try. Spelled T-R-I-E. This is a classic data structure. I need to show you an example of a try. Boom, boom, boom. Yeah, okay. Even though this looks terrible, I will... Okay, here we go. Window capture, you go to the front. Great. Okay, so... and I know you can only see... Here, I'll try to make it smaller again. So a try... This is kind of your standard... It's basically a special kind of tree where you're going to encode something like a dictionary, And you can't really, well, let's see. Maybe, what if I click on it? What could possibly go wrong? Because this is not a bad picture if you can actually see it. Let me see if you can see it once it pops up. Because I can't see what... Oh, yeah, that looks terrible. Nope, you can't see it. Damn it. And I can't move it either. Sorry. We'll just go back to here. Okay, so a trie, it's... Oh, fine. Let's do this. Let's make it... There we go. Something... Well... no. This one. This one. Yes. Okay. So we started a root, and then every time we go down a child node, the root can have 26 children, one for each letter. So we do B. Then what do we do for B? Well, underneath B, we could do U. Is BU a word? No. But BUY is a word. So that would go in. SEL, that's not a word, but SELL is a word. So each node has to know, does a word end here? And then it can have up to 26 children. This is not a great picture because one of the cool things about trie is it's really efficient. So if GO is a word, GO, so GO, a word would end here. But if gone is also a word, GONE, another word would end here. So the GO we used for go could also be reused for got and gone and go gadget legs from the Inspector Gadget show or something like that. Lots of different possibilities. Zoom out. Yeah, I'll zoom out again. But then you can't really see it. Or maybe you can because your eyes are young and vibrant, I guess. I don't know. Okay. Back to here. So what do we need? What do we know about a trie? Well, we have this Boolean which lets us know what if does a word end here. I'll just call it what do I usually call it? Word end, I guess. I don't know. And then we have children, possibly one for each letter of the alphabet. So let's do something like basically you use a hash map where the key is a character and the value is itself a trie, or you do an array 0 to 26. And then you sort of do your standard, 0 maps to A, 1 maps to B, and so on. I'm just going to use a hash map, so I'll do private map. I hate it. See, look at this autocomplete. This is a terrible default. Who is going to need com.sun.javafx.collections.mappingchange.map versus Java util map? This should be the default, that should be first. I don't know why Eclipse consistently does this wrong. I think it isn't doing it alphabetically because this package, oh yeah, no, it is doing it alphabetically. Yeah, it's doing it literally alphabetically. That makes no sense rather than by what would most, how is this a better default than that? That makes no sense. If you were to do a magical empirical study of all of the autocompletes in the history of using Eclipse, how many do you think are com.sun.javafx.collections.mappingchange.map versus Java util map? This should not be alphabetical. This should be based on most common usage. Or doesn't even have to be based on common usage. It should just be Java util goes first, and then everything else is alphabetical after that. Gah. This has been wrong since I've used Eclipse, going back to 2004. Eclipse is really good, but that's just a weird UI issue. Anyway, my keys are character. My values are trie. I'll call this children. No, I'll be a hipster and I'll call it kids because it's now I can't decide now. Do I go with the classic? Whatever. New hash map. Well, now this knows to do because I guess hash map is the only one that it's got. Now I think. Is it true that in Java 10 or whatever... Oh, look at that. I don't need to put the types here. It figures it out based on the fact that the types are there. Oh, that's amazing. Okay, good. So, what do we need to be able to do with this? Well, we need to be able to do public void insert. And this is also going to be a recursive. String word. Oh, this is so cool. Oh my god, I love recursion. Okay, watch this. If word dot length is 0, then I'm going to just do word end equal true, and I'm done. That means if I'm trying to insert the empty string, that means that this particular node, I'm adding the word nothing to it, so that means the word ends at the current node. Boom. We can't see? Oh, what can't we see? Switch to Eclipse? Am I not switched to Eclipse? Oh, I'm not switched to Eclipse! You can't see this! Oh, I'm so sorry. Oh, damn it. Okay. Well, sorry about that. My beautiful face is also gone. Yeah. So interesting. So faculty have a Slack now, and there have been some discussions about, doing video. It's just another reminder of how gender. I experience the world very differently through gender. So I've made. This is the only time I don't usually put my face in videos. It's only pretty much on here. But a couple of the faculty members were like, "Wow, I'm recording videos, but I look terrible. I need to put some makeup on. I got to change the lighting around." And I've spent no time thinking about that because as a man, people pretty much don't actually care what I look like, and probably the worse I look, the better, because they're like, "Oh, he's a grizzled old professor. That adds credibility to him." Whereas if I were a woman in my 40s, trying to stream video, and people would nitpick every single detail about me. So just another reminder of how I experience the world very, very differently through my maleness. Okay, so we're back here. Okay, good. We can see me again. Oh, thank goodness. Yeah, I need to learn how to do that better. I need to learn how to do all of this better. Really, I just need to be better at everything. Okay, so if we're inserting an empty string, boom, we're inserting an empty string. So that's just it. Otherwise, we're not inserting an empty string. So we know that there's at least one character. So we'll do this. Char first equal word dot char at 0. So we've got, and then we'll do string rest equal word dot substring starting at 1. Okay, so now this is the first character, this is the rest of it. Now what are we going to do? Well, we're going to check our children. And there's two possibilities. Either I have this character and a trie node underneath it, or I don't. So let's just ask. Okay, if kids dot contains key first, that means I have it. So what do? Well, I just take, watch this, kids dot get first. Now what type is this? This will tell me if I hover over it, it's a trie, right? Because that's my map. It's mapping from characters to trie nodes itself. So I get this, and then I'm going to call its insert method on rest, right? So recursively what I've done is I've now created this lovely situation where I've got the first character, and then I'm using that as the key, and then the rest of the string I'm then inserting that. Now the other possibility is that I didn't have the first character. So if that's the case, what I'm going to do is take kids, and I'm going to put, with first as the key, a new trie node. And then just do the same thing, kids.get. You know what, now that I think about, well, sorry, I'll show you what I'll write it and then I'll change it, because I'm going to refactor it immediately. Because I'm looking at this and I'm like, oh god, I've got this code is repeated twice and that just looks ugly, and so I'm not going to, well, whatever, I'm not going to mess with it. It's fine. This is fine. This inserts. I'm pretty sure that'll work correctly. We'll test it in a second. Now what I want to do is, I also need to check if it contains it. So I'm going to do public boolean contains and string word. Again, recursively, what's my base case? Well, suppose word is empty. So if word dot length is 0, right? In other words, if I ask a trie, and remember, a trie is just a bunch of nodes. It's just a root node with, some number of children below that. So you follow a letter to get to another node, and then you follow a letter to get to a node. And so each time you sort of use up a letter, and you follow that. And if you ever get to a point where you have letters and you can't follow them, then that word isn't contained in there. Or if you follow all the letters and you get to a node where a word doesn't end there, so maybe, I don't know, the word aardvark is in your dictionary, but you asked, do you contain the word ard, A-A-R-D? Well, A-A-R-D is not a word, so you could follow A-A-R-D, but that's not a word. A word wouldn't end there. So if word.length is 0, I just return word end. And that'll tell me, I missed your rant because the squirrel distracted me, but your face. Am I showing my face again? Am I visible again? I should be. Yeah, I should be visible. Oh, no, I'm not. Sorry. Hello? Yeah, there we go. I'm back. Sorry about that. Okay. Word end. Okay, otherwise, now I know I have at least one character, so I'm going to do the same trick. Char first equal word dot char at 0, and string rest equal word dot substring of 1. Nope. 1. Now I have two possibilities here. Either I have the letter first or I don't. So I'll start with not, because that's a base case. So if it's not the case that kids.contains key first, so if I don't contain it, then I can just return false, right? That means I got to some letter and I got to some node and I have a letter, but there's nothing under me with that letter, so nothing. Otherwise, I would return kids.getFirst, because I know this will succeed, because if it wouldn't have succeeded, I already would have returned false, and I'll do this dot contains rest. Ha! I'm pretty sure that'll work. Now we need to test this. So I'll just test it with main rather than JUnit, because I'm low on time here, because I think we're going for a walk at some point. Let's do this. Try root equal new try boom. So now what do I need to do? You know what? I need to read this file words. And I need to read it line by line. Okay, so how am I going to do that? I'll just use a scanner. So I'll do scanner. Oh, wait, scanner. Yeah, see, there's another one. Look at this. Look at this. This is a terrible default. What are the chances I want com.sun.javacup.internal.runtime as opposed to Java util? I mean, this must be... There's no way people haven't pointed this out, right? That this is the wrong default. And I have definitely had students use, like, autocomplete in Eclipse and get really weird things imported, and then because Eclipse sort of, like, buries the imports like this, not know it, and then have errors because they had, like, something shadowing something, and it was very confusing. Eventually, like, now I know to look for that when students have weird errors, but the first time it took me probably like a half an hour to help the student work through something. So this I cannot be the first person to point out that these defaults are weird. The only thing I can think of is Eclipse is not used by enough novices for it to matter, or this is never a high enough priority to fix. I don't know. Scanner. Scan equal new scanner. And I want to make the scanner attached to new file input stream. And I know that this can just be words.txt. And the reason I know that is, and I'll fix this exception in a second, just the way Eclipse works. So I'm inside this Boggle package, or Boggle project, and this words file is next to the source folder. So whenever you run something, it runs in the project folder. That's its default location. So if you don't give a path, if I just say, like, hey, this thing, this is what it'll give you. So I could literally ask for the source folder. That would be super meta. Like, I could open this file while I'm running this file or something. I don't know why I would do that, but I could. So I'm pretty sure this will just succeed. Now, the next thing we're getting is this exception, unhandled exception, file not found. I'm going to just throw the lazy exception. I'm not going to do a try catch. And I'll just do super lazy and just say it throws any exception in main. In general, you shouldn't declare that things throw exception. Well, in general, you shouldn't have checked exceptions anyway. I think I think C#, which came after Java, does just fine by not having checked exceptions. I think it's... I don't know about this, but I think... I would assume it's the case that people have decided checked exceptions are just not that helpful. I don't know. You just never know. Hey, we're up to 7 viewers. God, this is fun. I don't know why people don't do this not like this. I'm going back and looking at all of these different things. Oh, this is so fun. Our students are great. Okay, so now I'm going to say like while scan.hasNext. No. Do I want hasNext? Yeah, I'll just do hasNext. I'll do root.insert scan.next. Let's also do this. Let's do this. String word equals scan dot... No, I don't think I'll end up with an empty string because I'm doing next, so it should skip over white space. I could still get... Well, you know what? I know how to... Yeah, here we go. We'll just read... Okay, good. So now we're inserting all these words. So let's ask some questions now. System.out.println root.contains dog. Is dog in there? And I'm going to also ask, is the empty string in there? And I'm also going to ask, is, I don't know... How about this? We'll do the first word that shows up in chat. That's dangerous. I don't know what's going to show up. I think the stream is still on Chrome. Oh, right. Yeah, I'm looking at some of these previous messages. Huh. Good times. Oh, pounding some tea. Well, okay, what word do we do? I don't know. We'll do cat. The suspense is killing me. Let's run this. Run as. I have like a multiple second delay. Watch this. True, false, true. That makes sense. Dog and cat are in there, but the empty string isn't. So that's how I know that this scan.next is doing the right thing. It's not accidentally reading an empty string. I can also do system.out.println. What's a word that isn't in there? Whoops, that's not what I wanted. Root.contains. Well, let's see if it's in there. Petrichor, which we decided is smelling of the earth from one of our resident English majors. Petrichor's not in there? What? This is the worst dictionary I've ever seen. Actually, are we sure it's not in there? It's not in there. What kind of BS dictionary is that? Pfft, doesn't even have petrichor. Which we decided it was smelling of the earth or something like that. I don't know. Let's test with another word we're pretty sure is not in there. Blah, 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 blah. ASDF, which I pronounce as bleh. Okay, this makes sense. I think it probably worked. I know the dictionary was all lowercase. I could do stuff in here to like check to make sure it's lowercase, but I'm probably not going to bother. So now this code here, I'm going to steal this and just reuse it over here. And I'll just, oh, but I don't want this to be an, now we're getting, now shit's getting real. Now I got to deal with exceptions. Throws IO exception. I'll explain some stuff about exceptions in a second. This I don't want to be a local variable. I want it to be an instance variable. And I'll just call it try. And then here I'll also call it try. And then I'll make this a instance variable. Equal... Well, you know what? I don't need to because I already initialized it in here. Really? It can't be resolved? Why not? Because they called it root. That's why. Duh. Not tire. Gah! Blast! Okay. Right. What could possibly go... Oh, now this is throw... Yep. That's fine. Guess what, main? Come on. You throw an exception. Okay, so some notes about exceptions. This is something that happens all the time. When you're first programming, you learn you can try catch exceptions. You should almost never catch an exception unless you know how to fix it. So like in this situation here, I could put a try catch around this because I know that creating this new file input stream, like maybe I can't find this file or something. But if I can't find this file, there's no information being passed to the constructor that allows me to fix that, right? If it were the case that I supplied a file name here, then it might make sense, I don't know, to catch. No, then wouldn't even make sense. Here's a situation where if I can't find this file, this program will never work. So there's no reason to try and catch the exception. What would I do when I caught it? Like, I could print an error message. Well, guess what happens if it can't find the file? Like, what if I change this to, this? So now it's not going to work. Now let's run this. Let's run. Really? We're going to play that game now? There we go. Let's run this. So we run this, and then, boom. Hey, look. It crashed and printed an exception where it said file not found, this thing, no such file or directory. That's pretty descriptive. It also includes a stack trace, which tells me exactly, what line it happened at, which is pretty helpful. I couldn't do any better if I did a try catch myself, right? I may as well crash the program. And that makes sense because whoever called this method needs to know that this failed. Well, throwing the exception has the effect of that. Also, by putting this throws declaration here, anybody that calls this knows that it could throw an exception. So they kind of know that. So they can either catch the exception or they can throw it and it can just percolate all the way up to main. Main can catch the exception, but main can also just throw the exception and just crash the program. So in general, there's very few instances where you should catch an exception. You should almost always just throw the exception. And if you throw the exception all the way out of main and main crashes, that's fine, right? It's an exception. You should only catch exceptions if you can fix it. So situations where it makes sense to catch exceptions, if you have a GUI program where, the user types in a file name and you try to open it, or they click on a file name, with like a little, choose file or choose folder window, maybe they choose a file that they don't have permission to read. It makes sense to catch that exception because it's a GUI program. You can prompt them to enter it again. There's no prompting going on here. So if an exception happens, I can't fix it. Nobody can fix it. That just means the program's wrong. Something terrible has happened. Well, if something terrible's happened, either you're the developer and this exception lets you know what to fix, or you're not the developer and it's broken and you file a bug report. But in either case, there's no way to fix it. There's some internal problem. Right now, I have the wrong file name. So if I'm the developer, I go fix that. If I'm not the developer, I can't fix that. I file a bug report. So just don't catch the exception. Just throw the exception. It's fine. It's weird because crashing is good. You don't think of crashing as good, but crashing's totally good. Cool. So now we have this try. I'm pretty confident we can ask this try if it contains... Oh, no, I don't want to know just if it contains a word. Damn it. One other thing I need to know in this try, not just does it contain a word, but is a particular prefix on its way to a word. In other words, this just tells me, is this a complete word? I actually just want to know, is it a legitimate path? Okay, let's do this. Public Boolean has path, string path. This is going to look exactly like this, except I'm literally going to copy this. Has path, and I'm just going to cheat and call this word just so I can change less. But here I'm just going to return true. So I'm like, boom. The sweet smell of the earth after it rains. I know, they don't have petrichor. What is wrong with these dictionaries these days? Yeah, here's... So I've got some word. If the word is empty, then obviously that's a legitimate path in my try. Either that means I ask the root if it contains the empty string as a possible path to something else. Well, since the empty string is a legitimate prefix to any actual string, that's fine. Or it means that I've traversed some complicated set of nodes and I've gotten down to some place, but I'm still at a legitimate node. In either case, just return true. Otherwise, get my first, get my rest. If the first letter... There's nothing for it, then return false. Otherwise, go ahead and get it, and then get the subnode, and then recurse. Now, if you're looking at this and you're like, Spacko, you've got legitimate the same code in two different places, almost exactly the same code. You should probably have a private helper method. You're totally right. And since this is an educational stream, I will go ahead and do that. private trie, I'm going to call it traverse, string path. So what this is going to do is traverse a specific path, like whatever this path is. So if path is, no, that's not right. If path.length is 0, return this, right? So another, nope, that is not right. Yeah. Otherwise, char first equal word.char at 0, string, no, I didn't call it word, I called it path. Duh. String, rest equal path dot substring 1, and if it's not the case that kids dot contains key first, I'm going to return null. Otherwise, I'm going to return kids dot get first dot traverse rest. Okay, so this will either return, and this is sort of cool, return this. What I'm saying here is like, okay, suppose I ask the root, do you have a path empty string? It'll say, yes, I do, and it'll return a reference to itself. Otherwise, it's like, okay, let me get the first character and the rest, and then if I don't have the first character, I'm going to return null. So what this means down here is I will do try node equal this dot traverse word. So that gets me a node, and then I can say, since this has path, I'll return node is not null. Because if node is null, I don't have a path. I didn't get it somewhere. Otherwise, I do have a path. Now, what I would do here is I would do the same thing, but with a different return. I would say try node equal this dot traverse word, and I would say if word is null, return false. Otherwise, I would say return word dot word end. What did I call it? No, not word. Duh. Return. No, not if word is null. Yeah, you're right. That's stupid. If node is null, node dot word end. Ha! Look at that. Look at that. That's fantastic. Okay. Great. Yeah, so now I've kind of factored out that repeated code into this private helper method. And so what's cool is, like, from your perspective as somebody call it, by your perspective, I mean from Board's perspective, Board doesn't know I just did that. Board doesn't really care. Okay, good. So now, oh, shit, something I forgot. Why am I using a trie at all, this beautiful compact representation? Well, how many words are in words, this word list? Let's look at it. There's, 80-something thousand. That's a lot of words. I don't want, when I'm working with my my board here, I don't want, like, okay, HV, is that a word? Are there any words that start with HV? I don't want to have to do a linear scan of 84,000 things to figure out if something starts with HV every time. I could do binary search because it's sorted, and that would be log n in the size of the list. That would be really efficient. 84,000 split in half is what? 84,000, what's the closest power of 2? It's not that big because 64,000 is what, like 2 to the 16th? So that would be 16 steps. 17 steps would be 128,000, I think. Yeah, so it's like no more than 17 cuts to do binary search. So that's pretty efficient. A trie is linear in the length of the word, which is really not too bad. So we can figure out very quickly if these lead to something. Either one is efficient enough. A linear scan will work. It's just super inefficient. And then not doing anything and just completing the recursion, that's going to be exponential. You can't really do that. I mean, you can. It's just going to run forever. Okay. So we've got our trie. We've got our toString. Now we just need to start looking for some words. Okay. Well, we've got the board. How do we want to ask this for its list of words? Well, probably we want to print out the board and then we want to generate the list of words and then maybe print it. So do we want it to, well, probably we don't, probably the toString should just print the board. And then we should probably produce the list of words and then print it. So I'm going to put them in, I want to put them in a, I want them sorted. I guess I'll do this in the constructor. So now we have this trie of all the possible words. Well, now we actually got to start generating the words. Now we're ready to do some more recursion. Okay, so what do we need? Well, I'll make it private void, I don't know, find words. I need to know what letters I've already seen. I need to know what row and column I'm at. I need to know what I've already visited, which is going to be a set of coordinates I've already seen. And then I'm just going to say this is a set. I'm just going to leave that blank right now. What the types are, we'll talk about the types in a second. And then I also need to know a set of the, this is due to just be string, the words that I found. And I kind of want that set to be sorted, so I might make it a tree set, because that'll sort it, because a tree set is basically a binary search tree. So I think this is my recursive method for finding words. And then my visited set, I need a way to know that I visited the T at 0, 0, and I visited the H at 0, 1. I can do this any number of different ways. I can have a set of strings where I turn these coordinates into strings. I can, that's just what I'm going to do, because it's pretty easy. Set string. Good. Okay, so now what this is going to do is, watch this. I'll say tree set of string words equal new. Actually, I'll just make this a set like I'm supposed to. New tree set. Good. And now what I'll do, I need to do find words, but I need to do it starting at every location. So I'll do for int r equals 0, r less than 4, r plus plus, for int c equals 0, c less than 4, c plus plus, and I'll do a find words. I haven't seen any letters so far. I'm at row column. And my visited set is new. The visited can just be a hash set. New hash set. And words is just words. Great. So this just fires it off. And what's cool about this is void. It doesn't return anything. So anytime I find a word, I just stick it in this set. And what's really cool is, because it's only one set, it gets passed everything. Now, each recursion has its own visited set, and that's going to need to be true in this recursive method as well. I've made that mistake before, not going to make it again. Oh, what do we have? Can you please show us your kid? Yes. Real child instead of a child node. Very clever. I think she's sleeping. And we're gonna take her for a walk shortly. I'll let me wrap this up, and then I'm probably not that far from done, at least with what we're gonna do. But then, I mean, if not today, we'll get her on there at some point, maybe tomorrow. She's pretty friggin' awesome. I'm not gonna lie. She is just, everything about her is amazing. Oh, hey, there's messages on Slack. Oh, but it's the faculty Slack. Slackulty? Faculty Slackulty? Okay, so what are we going to do? Well, okay, let me think about this. So now what are we doing? Well, okay, prefix. So let's do string word equal prefix plus get letter at row column. Good. So that means that whatever letters I've seen so far plus whatever letter I'm currently at row column, that's what I've seen so far. Now, there's an immediate base case. If that can't bring us to a word, in other words, if it's not the case that my trie not if it contains a word, but if my trie doesn't have a path to word, then I can cut off this branch of the recursion. And the way I'm going to do that, I'm just going to say return. Since it's void, I can't return anything, but I can return nothing. So return semicolon, just return nothing. So that's going to kill the recursion. That's one way to end the recursion. Now what else do I need to do? Okay. Next base case, well, not base case, next thing to check, what if it's the case that the word I've seen so far, in other words, the prefix plus my current letter, what if that's a word? So if it's the case that my trie dot contains word, then I want to take my words and dot add word. Done. Okay. Now I need to do my recursions for all of the nodes around me, which can be left, right, top, bottom, diagonal. So it's basically that stencil. So how do I want to do that? Well, this is sort of stupid, but I'm going to do it with nested for loops because I'm unoriginal. So r equals 0. No, not r equals 0. R equal row minus 1. R less than or equal row plus 1. R plus plus. For int c equal column minus 1. C less than or equal to column plus 1. C plus plus. Now, some of those might be out of bounds. Because if I'm here, right, if I started my very first call up here, I did a find words, empty string, 0, 0, boom, I'm here. Well, obviously I can't go to the left, I can't go up, I can't go top left. So I'm just going to put in this one blanket check in here. So if it's the case that r is less than 0, or r is greater than or equal 4, or I could just say greater than 3, right, 0, 1, 2, 3. That maybe sounds more elegant. Or C is less than 0, or C greater than 3. Continue, because that obviously was illegal. There's one other situation where I need to continue, which is if row R equal row and C equal column also continue. Now I know there's probably some way to combine these ors with these ands. Actually, maybe it isn't. Maybe I'm over. Or just that? Because and has a higher precedence. So if any of these things are true or both of these, that's probably fine. I'm going to try it that way, and then when it doesn't work, everybody can heckle me. So that tells us, things we can't do. Otherwise, we just do the recursive call. So we do find words, the word I have so far, the new row column from this loop, my visited set. Oh, right, I need to add to the visited set. Well, okay. Here's a thing you can't do. Visited. Oh, we need to do our yeah, okay. What I'm gonna do this private static help. No, private static string coord, and this takes a row and a column and converts them to string. And I'm just going to return just row plus, a dash plus column. So it just converts it to a really simple string that we can stick into a set. Here's something you can't do. Okay, we can't just do this. Well, also we can't do this because we can't spell the word visited. But once we can spell the word visited, we also can't do that. Here's why we can't do this. There's only one visited set that this method receives. So we can't have it be the case that if I'm here and I do a recursive call for here, well, that's going to note that I've visited 0, 0. But then from here, if I do a recursive call to here, it's going to add that to it. But I still haven't done the recursive call from T to H. Well, we don't want to have O added, right? In other words, we can't just use one visited set here. Here's what we have to do. We have to make a new one for each recursive call. So we need to say set string, copy equal new hash set of visited. And I think I can just do this and we'll figure it out. Yeah. And then what we do is no, okay. Yeah, I can do this. This is fine. Because I've seen row column, but I do need to pass the copy. I can't pass the visited set because, like, if I'm at 0, 0 and I do a recursive call for row 1, column 0, well, the recursive call for 1, 0 can't use the same visited set as the recursive call for 0, 1. They have to be different visited sets. So each recursive call needs a copy. So I can add this once because, all of the recursive calls from T need to know that 0, 0 is now off limits. But the recursive call for here is going to note that O is off limits. The recursive call for here can't think that O is off limits. That's not going to work. So I make this copy here. And this is a thing that almost every class in Java and every other object-oriented language, it's called a copy constructor. It's basically like make a new one of these by initializing it so it has everything that thing's in there. And then boom, that's good to go. So Shazam, love it. Find words, blah, blah, blah. I don't know. This might work. Who knows? Find words. Great. This is just... You know what I'm going to do? I'm going to hoist this to here and make this an instance variable. I think that'll work. Oh, let me, just because I know a lot of people are coming right out of 142. When you do stuff like this, that gets hoisted and stuck in the constructor, right? So if you create an instance variable and initialize it, and then you don't sort of initialize it in the constructor, Java just sort of figures out like, oh, well, you meant for this to be at the beginning of the constructor, and it'll just stick it there for you. That's a fun thing that Java is able to do. This constructor has a lot of stuff in it. I would almost certainly, to do refactor. This should be a private helper method. Probably this might need to be a private helper method. Either all of this or each of these separately, I'm not really sure. This probably could be a private helper method. I'm not sure, though. I'll put that as an I don't know. And, good. I think... I don't know. I think this might work. Let's see. Okay, toString. Oh, we need a way to get that list of words out. Okay, private, public set of string get words. And this is just going to return this dot words, I guess, maybe. Oh, and I should mention, I made this a set. The words up here, I made this a set because I don't want it to have duplicates, and I made it a tree set, which is sorted because I want it to be in the same order. And you can sort of see right away the reason I don't want to have duplicates is, we can have the word ten, 10, but there might be a way to get 10 off of this. If like this were an E instead of an O, then you could have the word 10 two different ways. So you don't want the word 10 twice, you just want it once. That's why we want it to be a set without duplicates. And I'm doing tree set, which is basically binary search tree, so that's sorted. This also explains why binary search trees in Java, because they're tree sets, can't have duplicates, even though there's no real reason why a binary search tree can't have duplicates, like theoretically. Is because they implement the set interface. So that kind of makes a lot of sense. Okay, good. Everything looks great. Things are totally under control. Let's go here in main. Now we'll do... what does it look like when you print a set in Java? I have no idea. Let's find out. Print line board dot get words. I don't know. Let's see. Let's run it and see what we've got. Wow, the set's empty. Well, that sucks. Something went wrong here. That's never good. Huh. Well, okay. Let's look at, does, Huh. We did this. We launched to find words. We used words. Words was initialized. Now we're debugging. What do you know? This is visited. Nothing's been visited. That makes sense. What are the... Oh, people are probably looking at this and screaming right now. They're probably like... I'm just nervous that this somehow is wrong. If that continue. Okay. I don't know. Try it again. Wow, that's no good. Okay, well, how did we cut off the recursion? That's usually... So, the fact that it's coming up with a totally empty list usually means there's some stupid, like, I just didn't... things just aren't happening at all. So, we can all... Well, okay. This is... Well, fine. We'll just use a friggin' debugger. Oh, boy. Here we go. We're doing it. We're using the debugger. I can't believe it's come to this. Oh, yeah. Remember my decision, switch to the view. I hope you can still see this view. You can. Right? I hope so. Okay. Well, yep. You can see it. All right. So these are your buttons. So, wow. Well, we're debugging. Okay. Let's step into find words. No, I don't want load class. Let's step into find words. Nope, I don't want the hash set constructor. Let's step into find words. Ha! Good. This is where I should have put the thing. That would have been much smarter. Okay, let's step over. Whoop. What is word? Word is now the letter... Oh, you know why? Yeah, duh. I see it. Do you see it? God. I wish we had a little bit more interactivity, because then I could poll people and just be like, hey, does everyone see the stupid-ass thing Spacco did? Because I'm seeing it right away. Because look at this. Is that lowercase or capital? That's capital. Let's look at our list of words. Everything's lowercase. So, of course, it's not finding any words. They're literally not there, because capital and lowercase mean different things, as one maybe would want to know. Okay, so how do we fix this? Do we convert the dictionary to uppercase, or do we convert the Boggle board to lowercase? I'm going to convert the dictionary to uppercase, believe it or not. And how am I going to do that? Well, where do I read the dictionary? It's in the constructor. .next. Upper to uppercase? Yeah, we'll just convert everything here to uppercase. Let's try this again. Ha! Look at that. Oh, wow. Okay, so this is cool. This is cool. We've got zillions of words in here. They're alphabetical. V-I-V. V-O-L-T. Is the word volt in here? V-O-L-T. Is thine in here? Ha! It is. Yeah, okay. I'm pretty sure it's working. Pretty sure it's working. Gotha. Go-Go. The Go-Go's. We got the beat. We got the... Oh, Gogol. I think he was a Russian author. I remember I was riding an Amtrak train, and somebody just left a book in the seat back pocket in front of me, which was some Russian short stories. They weren't in Russian, like it was translated into English. It was really cool. That was actually the second time somebody left a book in a seat back. I also found a Choose Your Own Adventure book when I was in elementary school, and Choose Your Own Adventure books was all the rage, in the seat pocket in front of me when my mom took me to Florida when I was in, I don't know, like second grade or something like that, to see my grandmother and go to Disney. And I, misinterpreted what had happened. I didn't realize that a child had been sitting in the seat before me and put the book in there and left it there and forgotten it. I thought that just, everyone got Choose Your Own Adventure books on planes, and I was like, air travel is amazing! Those are good times. I'm pretty sure this is working. But I don't know what the minimum length word in Boggle is. I'm pretty sure this is not allowed. It's probably at least 2 or possibly 3, but that would be not too bad, because what we would do in here is, like, how long do we want them to be? I don't know. 2, 3, 4, who knows? Let's do, who knows? I don't know. I should interact with chat more. I gotta figure out how to get this to go faster, like where I can see what's going on. Let's do, well, you know, this is knowable information. Boggle minimum length word for a standard 4x4 Boggle. Words must be at least 3 letters. Easy enough. Okay, so what we'll do is, when we are... Where's find words? Where are you, Recursion? Hello? Find words. Get words. Find words. Okay. Yeah, here we go. If it contains the word and word.length is greater than 2, add it to the word. Otherwise, don't. Okay, now let's try it again. Great. Okay, so now we only have the 3-letter words. This looks terrible. I'm gonna break this down to one line. Down here, I'm gonna say for string s in board.get words. System.out. Does this do the SOP? Yeah. Oh, did you see that? Oh my god. No, it's just S. And I'll put like a couple of spaces here. Wait, let me start doing that. Nope. Oh, I love that. I'll just do some random space in there, and then let's run it again. Yes. Love it. Oh, cool. Okay. Oh, and we want to know how many there are. That would be a good way. That would be a good thing to do. Board.getWords.length. No, not parallel stream. What in the hell was that? What? Can we not get the length of this? Oh, no, it's size. Duh. What do we got? Boom. 108. If you were to let me do this for more than the 3 minutes in Boggle, if you were to let me to like work on this for like an hour, I probably couldn't get. I probably could get 20 words. Also, I didn't know gov is a word, and you know, you're sort of at the mercy of your dictionary, whatever dictionary you're using. Okay, well, this is looking great. I'm hoping that this. So I will. Okay, how am I going to make this code available? I will put this on GitHub so that you'll have the code. And I'll make the video available, and then yeah, and so this is just like, this is not like cool, but people thought we were gonna end up with like actual cool thing. Basically, just wanted to show off some recursion and a little bit of kind of stuff that has to do with object-oriented design. So you know, take-home messages from this: don't catch exceptions unless you know what to do with them. You should very, like, unless you're convinced that I know what to do with a try catch here, like I know what to do when I catch this exception, just throw the exception. Other things we learned that were kind of interesting. Oh, recursion is great. Use recursion when you can, because it's lovely. String buffer, this is just the thing. Like, especially if you're building big, complicated strings, this is just going to be more efficient because string buffer is mutable, whereas string in Java is not mutable. So if you keep doing string concatenation, it has to create a new, like, unique string every single time. So it's just more efficient to use a string buffer. For an example like this, that's a 4x4 grid, it's irrelevant, but I just wanted to show that off. And you'll see this. There's also a thing called string builder. I'm old, so I use string buffer, but I don't know the difference between a string buffer and a string builder. But everyone uses string builder now. Maybe I should learn to use string builder. I don't know. We learned about sets. We learned about maps a little bit. Oh, another thing. You notice I'm always using like the interface type set or map, and then I'm actually initializing it to tree set or hash map or whatever it is. The reason I like to do that, and most programmers like to do that, is, you know, this is just saying like, okay, it's a set. So I know, no duplicates, and I can ask, add and contains, and that's about it. And then over here, I could change this to hash set or tree set or whatever I want. By not committing here, I'm not forcing myself to, I could swap this in later. So like imagine I started out with a hash set and I was like, you know what, when I run this program, these are in some random order. I kind of want them alphabetical. I could then change it to a tree set by just changing right here. If everything here also said hash set, then any place that used words, I would have to then go change it, right? Whereas I don't really want to do that. So that's another thing you see programmers do all the time. Your variable declarations should use the least specific type. And this is just standard object-oriented Liskov substitution principle, LSV. Here you've got a base class type, or it's really an interface, but a type that's higher on the inheritance hierarchy. And here's something lower on the inheritance hierarchy. So you see this all the time in object-oriented programming, and something you should want to get used to. Yeah, I've got some refactor notes to refactor things and make them more robust. I don't know. I'm enjoying this. Something that I might do. So like this here, I would probably refactor this into a method. So I would probably do something like private void, and here's how I would probably do it. Make try, and I would probably do string file name. And then this, I would probably also have this, throws. Oh, actually, let me show you another trick. I know, so I'm going to basically take this code and stuff it in here. And then I'm going to call it with make try with words.text. Now, this can throw the exception. Oh, let me change this. This should be file name. This can throw the exception. Here is a thing you can do with surround with try catch. Surround this with try catch. Also, this is the auto-generated. Never do this, right? Why would you bother with this? Also, let me move this so that this makes any sense. Just print this, You're giving this code to somebody else to call, potentially. How do you know they're sitting there watching it? Imagine a long-running server process. Do you think there's somebody at Google that, watches the console for error messages? No. That's not a thing. Here's what I'm going to do. I'm going to catch this exception, and I'm going to throw new... I need to figure out a runtime exception. Well, I can't think of any, so I'm just going to do runtime exception out of E. Can I do that? Yes, I can. So... This is sort of cool. What is this complaining about? Resource leak? Oh, well, fine. After this is done, scan.close. That's complaining because a scanner is basically opening a file and forgetting to close it in Java, if the file's local, is almost never going to be a problem. But opening a file that's actually, or opening a resource that's like a database connection, or a network connection, those you do need to close. You don't want to kind of leave those open. But so here's what I've done. Now I'm catching the exception if it happens, but it's only the file not found exception for this, and I'm just repackaging it as a runtime exception. In Java, there's two kinds of exceptions. There's checked exceptions, which are, IO exception thing, anything where a method declares a throws saying hey, this is a checked exception. Anybody that calls main now needs to know that this can throw an exception. But now what I've done is I've caught the checked exception and rethrown an unchecked exception. So now this can just throw an exception anytime and nobody knows it might throw an exception. That might sound bad, but think about it. We don't, null pointer exception is an unchecked exception because a null pointer exception can happen at almost any line of code. Index out of bounds exceptions can happen at any line of code that uses an array or something like that. So now what this means is up here, I don't need to do this anymore. Boom. That exception goes away, which means that down here, this exception goes away. Boom. Now the exception could still happen. It's just a runtime exception. I don't have to have all those throws declarations kind of polluting my code. So that is a place where you sometimes see people catch a checked exception and rethrow an unchecked exception. Now, whether I should be throwing runtime exception or some more specific unchecked exception, I don't really know. I'm not gonna get into that right now. Let me show you what happens just so that you'll know if I where did I just put that? Hello, knock knocking on. Yeah, here we go. So suppose I change this back to words. Now I rerun this. Boom. Yeah, we still get this. Now we get, it was a runtime exception, which was made out of a file not found exception, that this wasn't found, da 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 da. So we're still getting the same information. It's just that this exception has been sort of wrapped around with another exception, right? So, like we've sort of encapsulated an exception with another exception. But does this really tell us less information than if we had the signature saying like, hey, this could generate an IO exception? No. This actually, I would argue that this is now better because it's taken this private detail, like, that this file may or may not be there. I'm pointing at the screen. You can't see me touching the screen. I don't know why I'm doing that. This file may or may not be there. The user doesn't care about that. That's out of their league. Not out of their league. It's like that's like below their pay grade. Like we're the programmers. We're implementing all this stuff for them. They're the people using the code. Like they're our clients. Like they're paying us to handle this stuff for them. It's below their pay grade. Cool. Well, I should probably wrap this up. So this is Boggle. This basic like get the dice, generate the board, and figure out all the possible words. And you've got two different recursive things, the recursive method itself plus the trie. I've implemented this. This is probably the 6th or 7th time I've implemented this in the last 10 years. I try to do it every year, but some years I don't. Or I start it in class one day, like if we have a day where I don't really have a lot going on, or like usually when students are really tired, like at the end of the term, I'll be like, let's do Boggle today. So that way people can like fall asleep if they want to. But it is good to periodically, do something. It doesn't have to be Boggle, but just anything that to practice your skills, especially if it's something you did a year or two ago. Because if you can't do it, then it didn't, like, something about it didn't stick. Cool. So how do hopefully I'll be able to keep this. Great, good times. I think I'll stop streaming now.